Now we are going to discuss about application of Gauss law. In this lecture we will discuss electric field intensity due to a long charged wire. What is the heading? Either what we can say, this is the application of Gauss law. First application we are going to discuss electric field intensity due to a long straight wire. This is the first application of Gauss law that we are going to discuss. Okay, so for that what you can do, you can draw one diagram here. You are going to take one long straight wire like this, and this wire is fully charged like this. We need to find electric field. So how we can find the electric field? Because it is a application of Gauss law. So what we can do, we can consider one Gaussian surface like this. What we are going to consider, like this Gaussian surface, we are going to consider this one. And another things, we are taking the length of this wire. How much length we are going to take here? This length we are going to take here to here. Yes or no? So for that we are considering one Gaussian surface. What we are telling this one? For this we are telling Gaussian surface. So for that, if supposedly you are going to be consider here to here, where this to this here, this one, r distance. At r distance you are going to be consider one point P, and this corner you are taking one small element area like this. Yes or no? So according to this diagram, you are taking electric field along this direction. Yes or no? So this area also you are considering in same direction. Is it okay or not? You can also mention here unit normal vector, no problem. So first you can consider this condition. You can consider electric field you are going to find here first. Okay, so electric field will be, how much electric field will be here? So distance is there, so we know very well that electric field formula. But we are going to discuss that application of Gauss law. So we will consider electric flux. Electric field line are passing here. So we are taking that small elementary area like this. So we can tell here that numbers of electric field line are passing. So this surface, from this surface, how much electric field line are going to be passed? So that measurement of numbers of electric field lines, this per unit area, is called electric flux. So first we will discuss electric flux due to this elementary area. After this, what another surface you can consider, either you can take, so we can take similarly here also. Here we can take one surface like this. Okay, so electric field will be along this direction, but surface area will be, you can consider like this. Yes or no? So you can also write like this, area normal vector like this, n cap also you can write. Similarly, if we are going to take another surface, so what surface you can consider here? Same you can consider here another surface here also. Like this is suppose that you are going to take. So it means this is the electric field you can consider, and this is you can consider that direction of the area of that small portion. Okay, this is a small portion. Clear it out? It means you have three corner, it means 3 point where you are going to be find electric flux. Here you are going to find electric flux. Here is also going to find electric flux. Here is also you are going to find electric flux. Then if you are going to add that all electric flux, then you will take total electric flux due to this charged wire. Yes or no? So see, look at the board. Very simple. Total electric flux. Total electric flux. So total electric flux, if you are going to be consider, so what you can write here, you can write in a very simple way, phi E is equal to, phi E means electric flux. Is it okay or not? Very good. So total means, so you can consider this one first surface and this one second and this one third. Yes or no? So you can write here phi E is equal to this closed integral of first surface. This you are going to be consider. So you are writing here E dot dA. Is it okay or not? Similarly, that electric flux for that second surface. So you can write here E dot dA. Is it okay or not? Similarly, for this third surface like this, so you can write E dot dA. Yes or no? So you know very well E dot dA is equal to, you wrote already, E dot dA, you can write E dA cos theta. This theta is the angle between area and electric field. Do remember this thing. So you can see here, this surface, what is the angle is making here? 90 degree. Here is also 90 degree. And here both are, we can consider that parallel. It means same direction. So it means what we can consider? Angle 0. Is it okay or not? So now we can place, we can substitute the value. So what we can write? Phi E is equal to, here we can write closed integral, first surface area we are taking E dA cos 90 degree. Either first you can write theta, and don't be confused, okay? So cos theta. Similarly here also for this second, so here also you can write E dA cos theta. Very good. And for the third surface also you can write E dA cos theta. Clear it out? No doubt. So now you can write phi E is equal to, for this one, theta will be 90 degree. Here is also theta will be 90 degree. So first and third theta will be 90 degree, and here theta will be 0 degree. So you can write here this closed surface area for the first, so E dA cos 90 degree plus second, you can write here E dA cos 0 degree plus for the third E dA cos 90 degree. So cos 90 means 0, you know very well. So you can write here phi E is equal to, it will be 0. So 0 plus only, it is cos 0 is equal to 1. So you can write here this one E dA. Is it okay or not? Very good. So it will be also 0. So you can write here phi E is equal to, what you can write? E, that second, like this you can write here dA. Okay, for the second. So second surface, due to only this second surface area you are considering, so because of that you are going to find electric flux. So you can also write here, what you can write? Phi E is equal to, so it means it is a cylindrical area like this. Cylindrical you are going to be considered. So you will take the surface area of the cylindrical. Okay na? Cylinder you can say also. Okay. So cylinder means you can write here E into 2 pi r L. Yes or no? Because this area you are going to be considered 2 pi r L. You can also write capital A, no problem. This closed integral of the elementary area you are taking a dA. So you are going to take complete here also, here also, here also, here also. So total you are going to take mean, so you are going to integrate. So you are getting 2 pi RL. It means area A. You can also write A is equal to 2 pi RL. No problem. Till here any doubt? So you can say this one equation first. After this, very important things are there after this one. What important things? You know one thing, that what things you know very well. We know one things, if suppose that we are getting that linear charge, it means linear charge means charged on line. So here is a straight wire. So we know very well linear charge density. So linear charge density concept, you know that linear charge density means, therefore linear charged density. So linear charge density formula, you know, can you tell me? Tell fastly. So linear charge density means you can write, you can give the symbol lambda. So linear charge density you can write here, this is a charge, linear charge density. Okay. So it means charge per unit length. So you can write Q over L. Is it okay or not? So you can write here Q is equal to lambda L. This one you can consider equation number 2. According to Gauss law, because according to Gauss law, according to Gauss law, you know electric flux formula. So electric flux, it means phi E is equal to Q over epsilon naught. Yes or no? This is the equation number 3. So you can write equation number 3 like this also, and after this you can substitute the value also, Q value from here. Okay, no problem. So if you are going to substitute the value, so it will be lambda L over epsilon naught. So you can write here equation number 4. So now you can comparing equation 4 and first like this. So from equation first and 4, from equation first and 4, so you can write here, what you can write, E into 2 pi RL is equal to this one first, and then 4 lambda L upon epsilon naught. Is it okay or not? We need to find electric field intensity E. Here electric field intensity, it means E. So E is equal to, you can write 1 upon 2 pi RL into lambda L upon epsilon naught. So L will cancel. Is it okay or not? So you can write here E is equal to 1 upon 2 pi epsilon naught into lambda over R. So this is a required formula. What is this? Required formula. Required formula, electric field intensity formula. So this is the final result, electric field intensity due to a long straight wire. So due to a long straight wire, we can also write due to a long straight charged wire. Both are okay. Is it okay or not? So now you can make note down. You can pause the video and you can just write down these all things. And after this, if you have any query, any problem, any doubt, so you can give the comments also, and either you can join the WhatsApp group also. Subscribe this channel for upcoming lecture. So now thank you so much. We will see you in the next lecture.